Hi, my name is Krapivnyi, and I will present the work influence of the natural content of mineral impurities and moisture on the manifestation of hazardous properties of coal seams. So, it's not possible to determine the type of coal in terms of reducibility from thermal decomposition without access to air, volatile materials to dry ash-free method, which provides establishing the ratio between oxygen content and other essential components of organic mass. Methods for determining the yield of volatile matters make it possible to assess the effect of the main components of organic matter and mineral impurities of the hard characteristics of coal seams. Determination of the hazard properties of a seam in relation to metamorphic transformations factors should include a case-by-case examination of the relationship between the major components of fuel, both the organic and mineral, including the moisture content for each coal seams. For now, all current Ukrainian regulation on safe mining do not use indicators that directly characterizes changes in the elemental composition of coal due to metamorphic processes. So, the influence of coal elemental composition on hazard expression remains largely unknown. There is changes in the elemental composition of organic mass during geological process are established for most coal seams in Donetsk and Lviv basins when determining the consumer properties of coal. So, all types of solid fuel contains, in addition to the organic mass, a mixture of mineral substances. When the fuel is burned and the mineral components undergo a series of transformation to form ash, the purpose of enrichment is to reduce the yield of ash. Coal is typically enriched with more than 10% ash. But when drying coal in the air, free moisture from the outer surface of the pieces and capillary moisture from open cracks and pores shall be removed. So, in our research, the elemental composition of the organic mass is determined without considering the moisture content on which the physico-mechanical and physico-chemical properties of coal miners largely depend. One of the main elements that can influence the hard behavior in mines is oxygen. The methodology is based on the fact that the consumer qualities of solid fuels are determined on the basis of analytical samples brought to an air-dry state. The results, which are expressed in other fuel conditions, are calculative. The calculation, on the other hand, is made on the basis of ash content, humidity, and mineral mass. Calculations, you can see right here. In the present case, we have formula from a dry ash-free state and for organic mass. The enrichment process contributes to the removal of some mineral impurities, which improve the quality of coal consumption properties. The ideal hypothetical enrichment option is to remove almost all mineral impurities. So the mutual location of the bisectors and the average line, as well as the regression coefficient and the free term of the equation, indicate that the mineral impurities residue after enrichment causes a relative decrease of oxygen content, on average from 3 to 7%. This relative decrease increases with the oxygen content on the combustible mass. An entirely different error is obtained when the oxygen content is recalculated to conditions close to the mining, under which the hazard properties of coal seams occur. For this case, trending is also characterized by a high correlation coefficient, but it is much further away from the bisectors of the coordinate grid. This follows from the values of the regression coefficient of equation 1 and the absence of a free term. The influence of the natural content of mineral impurities and total moisture of the relative average decrease in oxygen content when converted to the working condition of coal is estimated on average to be 19%. The mutual location of the bisectors and the average line, as well as the regression coefficient and the free term of equation, indicate that the mineral impurities residue after enrichment causes a relative decreases of hydrogen content on average from 6 to 13.5%. The influence of the natural content of mineral impurities and total moisture on the relative average decrease in hydrogen content when converted to the working condition on coal is estimated from 17 to 29.5%. The reduction in its content when measured by the working condition, taking into account the actual discharge of ash and total moisture in the coal of each seam, is in absolute terms within the range of 1.25 to 2.85. This follows from the resulting dependence and related graphs. A comparison of the graphs in this work, like on Figure 1, Figure 3, and Figure 2, Figure 4, show that the pre-enrichment and consideration of the elemental composition for dry ash-free coal samples predetermines a practical functional dependency from oxygen hydrogen content. However, the reference state of the sample taken for calculation does not correspond to the natural state of coal in the work area, and the actual mineral impurities and moisture content are not taken into account. The total moisture content is one of the main indicators of the degree of coal's metamorphism, but it is generally not used in regulation to predict the hazard of miners. It indicates that it is possible to individually characterize a coal seam by oxygen and hydrogen content calculated by the working condition, taking into account the values of total moisture and total ash. In conclusion, the formation and manifestation of dangerous properties of coal seams, judging by the requirement of current regulatory documents, are determined by the degree of metamorphic transformation of fossil coal. The use of these indicators for the prediction of dangerous properties of coal seams instead of indicators for the working condition can lead to errors in the determination by 50 and 45% respectively. This is caused both by the significant and possible content of mineral impurities in fossil coal and by the simultaneous presence of the main components that determine the dangerous properties of coal seams, both in the organic and mineral parts of fossil coal. Thank you for your attention.